Betelgeuse, a large, red, awesome, massive star placed inside the Orion constellation, has fascinated humanity for hundreds of years with its excessive red radiance and sizable size. Astronomers have predicted that if Betelgeuse were to be positioned at the center of our solar system, it would consume all the planets up to Jupiter. This star's vastness signifies it is nearing the final segment in the existence cycle of stars like it, preparing to culminate in a catastrophic explosion referred to as a supernova. In recent years, however, Betelgeuse has exhibited extremely unusual behavior. Its luminosity surged by more than 50%, catapulting it from the 10th to the 7th brightest star in the night sky. This surprising flare of brightness led scientists to scramble for answers. Was this an early warning of its explosive dying, or merely a brief blip in its life cycle? The ramifications of this are mammoth. If Betelgeuse were to go supernova, it may brighten the night sky to the extent that it would turn night into day, creating excellent scientific possibilities. A star's brightness is influenced by its size, temperature, and proximity to Earth. Betelgeuse, with a radius more than 700 times that of the Sun, is surprisingly cool. With surface temperatures around 3,000 Kelvin, this gives it its signature red hue. Size, combined with its low temperature, makes it a prime candidate for a supernova, making its recent behavior all the more intriguing. In late 2019, Betelgeuse shocked astronomers all over again by dimming to just 40% of its ordinary brightness. This dramatic change, visible even without telescopes, triggered widespread observations and debates. Some speculated that dust might have obscured the star, while others considered internal processes at play. The possibility of an imminent supernova became a key topic among experts. Using the Very Large Telescope VLT in Chile, astronomers managed to capture detailed images of Betelgeuse during its dimming phase. These images revealed that the star had taken on a notably lopsided appearance. Further analysis suggested that this dimming was likely resulting from a massive surface mass ejection, in which Betelgeuse expelled an enormous quantity of material into space. This exceptional event altered the star's appearance and disrupted its pulsation cycle. The event was akin to a volcanic eruption, only on a cosmic scale. Betelgeuse ejected over 400 billion tons of material, far more than typical solar events. This upheaval not only modified the star's appearance but also shortened its expansion period from 400 days to just 200. Such radical changes indicated that Betelgeuse is becoming increasingly unstable, sparking further questions. How much longer can it maintain its current form? Because of its unstable behavior, astronomers have ramped up their monitoring efforts, eagerly searching for signs of its impending collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under the weight of its own gravity, triggering a supernova. This massive explosion releases a tremendous amount of energy, blasting the outer layers of the star into space and creating an astonishing light display visible even during daylight hours. Should Betelgeuse explode, the initial sign would be a burst of neutrinos, tiny subatomic particles that travel faster than light and can escape from the star. These neutrinos might reach Earth hours before the light from the explosion itself. Once the light does arrive, Betelgeuse could shine brighter than the full moon, casting eerie shadows and illuminating the night sky for weeks. A supernova of this magnitude would present an unprecedented opportunity for scientists to study stellar death in real time. By analyzing the emitted light, heat, and radiation, researchers could acquire valuable data about stellar evolution, nuclear physics, and the formation of elements essential for life. To understand Betelgeuse's unusual conduct, scientists are utilizing advanced simulations to model the star's interior. These virtual models incorporate data from telescopes like the James Webb Space Telescope, JWST, and the VLT, allowing researchers to delve into the processes driving Betelgeuse's instability. These simulations have shown that a massive gas bubble likely formed deep within the star, triggering and altering its pulsation rhythm. Observations from the JWST have provided a closer look at the material ejected by Betelgeuse, unveiling intricate structures of gas and dust surrounding the star. These findings suggest that Betelgeuse may be nearing the final stages of its life cycle, providing an extraordinary window into the existence of massive stars, while scientists predict that Betelgeuse could go supernova in the next 10,000 to 100,000 years. Its erratic behavior suggests the timeline may be much shorter. The astronomical community is racing to capture every detail of this cosmic spectacle before it reaches its dramatic climax, ensuring humanity does not miss this rare event. In late 2023, the JWST, with its unprecedented observational capabilities, focused on Betelgeuse and uncovered startling new phenomena. Scientists discovered that the star, already in a state of instability due to its massive surface mass ejection, had undergone a rapid internal collapse. This collapse was indicated by significant changes in its core dynamics, which altered the flow of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Betelgeuse's expansion cycles before the collapse, with the star's surface expanding and contracting gradually over 400 days. Later, this rhythm was suddenly shortened to just 200 days, signaling a massive disruption in the star's internal structure. These irregularities served as a cosmic heartbeat, signaling that Betelgeuse is likely approaching the end of its life as a red supergiant. Simulations conducted by astrophysicists revealed that the core of the star is becoming increasingly volatile as it fuses heavier elements. When stars reach this phase, they begin producing iron, a process that marks the final stage before collapse. Unlike other elements, iron does not release energy when fused, causing a buildup of mass that eventually forces the core to collapse. Betelgeuse's recent behavior has sparked heated debates among astronomers regarding the timeline for its supernova. While some argue that the explosion could occur within the next couple of centuries, others believe it may still be thousands of years away. What is clear, however, is that Betelgeuse's time as a red supergiant is drawing to a close. One of the key signs that a supernova is approaching is a surge in neutrino activity, tiny subatomic particles that escape from the star's core moments before it collapses. Scientists are closely monitoring Betelgeuse for any sudden spikes in neutrino activity, and instruments around the world are on high alert to detect this fleeting signal, which could provide humanity with its first real-time warning of an imminent supernova. While Betelgeuse's supernova would be an awe-inspiring celestial event, visible even during the day, scientists assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, casting odd shadows and illuminating the night sky for weeks. This event will not only captivate stargazers, but also provide an unheard of opportunity for researchers to take a look at stellar loss of life in real time. The tale of Betelgeuse reminds us that the universe is still packed with mysteries waiting to be discovered. This full-size big-name star, which has mesmerized humanity for hundreds of years, continues to venture our information of stellar evolution and cosmic dynamics. As Betelgeuse surprises us with its dimming mass ejections and unpredictable conduct, it serves as a reminder of how much we still have to study. Its capacity to go supernova offers scientists an exquisite opportunity to look at the life cycle of huge stars firsthand. Understanding these tactics goes beyond unraveling the destiny of one celebrity. It's about unlocking the mechanisms that shape galaxies, seed the universe with essential elements, and even make existence viable. This knowledge expands our know-how of the universe's history and our vicinity within it. The tools we use to look at Betelgeuse, from ground-based observatories like the Very Large Telescope to cutting-edge instruments like the James Webb Space Telescope have opened new windows into the cosmos that past generations could only dream of. These technologies allow us to conduct simulations, observe stellar dynamics, and peer billions of years into the past, all to better apprehend the very material of reality. For scientists like Neil deGrasse Tyson, discoveries like these spark exhilaration and urgency. They push the boundaries of human knowledge and challenge us to preserve exploring the cosmos. The next time you look up at Orion's belt, take into account that one of those points of light tells the tale of a star on the point of its destiny. What do you believe will happen to Betelgeuse? Are we witnessing the very final moments of a star about to explode? Or is it just another section in its mysterious existence cycle? Share your thoughts and be part of the conversation about one of the most fascinating stars in the universe. Remember to like, subscribe, and turn on notifications for more cosmic stories that will leave you in awe. Until next time, maintain your eyes on the skies as we continue to look at Betelgeuse and its conduct. It becomes clear that this star isn't always just a fleeting spectacle in the night sky. Its unusual activity is presenting astronomers with rare opportunities to observe the intricate strategies that govern the evolution of huge stars. Each shift in brightness, every surface mass ejection, and every surprising change in pulsation patterns brings us closer to understanding the mechanics of stellar life cycles. One of the most captivating components of Betelgeuse's evolution is the reality that it is in a notably uncommon segment of its life cycle. As a red supergiant, Betelgeuse is nearing the end of its existence, but its path to supernova isn't as straightforward as it might seem. The exact reasons for the irregularities in its behavior are still being debated by scientists. While the surface mass ejection is one of the most dramatic activities observed so far, it may be just the start of a more complex collection of changes that result in the star's eventual collapse. What's equally intriguing is that Betelgeuse's supernova could provide answers to some of the most fundamental questions in astrophysics. The explosive death of a star like Betelgeuse holds the potential to reveal secrets about the nature of dark matter, the expansion of the universe, and the intricate processes that lead to the formation of new stars and planets. These revelations could assist scientists in refining present-day models of the cosmos and gaining a deeper knowledge of how the universe has developed over billions of years. The research being carried out on Betelgeuse is part of a broader attempt by the worldwide astronomical community to understand the life cycles of large stars. By studying stars like Betelgeuse, scientists can learn about the end stages of stellar evolution, which are notoriously tough to take a look at in real time. Most stars die in processes that are extraordinarily remote and difficult to witness. So when a star like Betelgeuse starts to reveal symptoms of its final explosion, it offers an extraordinary possibility to look at this cosmic process up close. One of the questions that remains unresolved is how long Betelgeuse has before it sooner or later reaches the supernova stage. The timeline for the star's death is still unclear, and scientists are constantly adjusting their predictions based on new information. Some astronomers believe that Betelgeuse could explode earlier than anticipated, while others assume it may take thousands of years before the supernova occurs. Regardless of when it happens, the excitement surrounding the star's eventual explosion remains palpable. For now, researchers continue to monitor Betelgeuse closely, using a variety of state-of-the-art instruments to seize every bit of data they can. From ground-based observatories like the VLT to space telescopes like the JWST, scientists are making use of the modern era to peer into the depths of this large star. The statistics they collect will help refine our expertise of stellar evolution and provide insights into the forces that drive the universe itself. As Betelgeuse's story unfolds, it serves as a powerful reminder of the vastness and complexity of the cosmos. The universe is full of stars that undergo great transformations, but few offer such a clear window into the final stages of a star's life as Betelgeuse does. Its forthcoming supernova will be a significant event, one that might assist scientists in answering some of the most profound questions about the nature of stars, galaxies, and the universe as a whole. While we may not yet know exactly when Betelgeuse will explode, one thing is certain: its eventual demise will be a momentous event in the study of stellar evolution for astronomers and scientists around the world. It is an event that will provide endless possibilities for discovery and development in our expertise of the cosmos. And for the rest of us, it will be a reminder of the superb beauty and mystery of the universe we inhabit.